everyone's probably seen this phrase. Werner Vogel is the CTO of Amazon, and he said this in an interview in 2006, you build it, you run it. What that meant was that if you are at Amazon and you build a service, you're processing credit cards or selling shoes or whatever it is, then you're responsible for running that service. Okay, so that includes if it goes out in the middle of the night, et cetera. John Willis, one of the original DevOps people, would say idea to cha-ching, so you're getting money and so forth. I think to take it even further, it's telling you actually retire it. But what's important here is the why. A lot of people have utilized this phrase to encourage things like no ops, and we don't need operators anymore, we don't need certain kinds of testers anymore, and et cetera. What's important is to look at the entire article. And I will publish the slides later, and they'll have all the links. Oh, the links cut off on the bottom there, but you'll have the links later. The important thing is why they did it. Okay, it was actually to shorten the customer feedback loop. It was to put the development teams closer to the customers so that they knew that if they changed a feature, that sales went up or down, so they can react to that and so forth. It wasn't about no ops or even DevOps, frankly, at that point. Now, about the same time in London, some folk at ThoughtWorks are working on a project. And if you're not familiar with ThoughtWorks, we have no problem with having not enough ego, which is not always a good thing. And frankly, we thought we knew everything. A few years before that, our chief scientist, Martin Fowler, had defined continuous integration. He would want me to point out that he wrote it down, but people have been doing automated build and test for quite a while. So we thought we were pretty good at this. We had built the first or second continuous integration server. So we built cruise control, and depending on what you think, if you think Mozilla Tinderbox was a CI server or not, so it doesn't really matter. But in 2001, we built a server to do automated build and test and so forth. And then with apologies, we also created Selenium. So it got a lot better in the 15 years since then. But we were doing all these things about automated tests, and we thought, hey, we're pretty good. We got this pretty well down. So in this project, and there were several like this, but in this one, there's a Java project. And for anyone that's been around at this time, one of the big things that Sun Microsystems liked to promote about Java was the whole write once, run anywhere. We all said write once, debug everywhere, but this is what it was actually done. And so the idea was you could write on one operating system and deploy to another, and it was supposed to just work. So this particular project, all the development team was on Windows laptops, and they were deploying to a Solaris cluster was the ultimate goal. But now, while the project itself was running good continuous integration and good agile practices, the overall, I guess, I don't know what the right word even to use is, the overall project at the company wasn't even going to acquire Solaris hardware until several months in. So the definition of done for the project team was that the product manager or some kind of advocate or something like that had signed off on the functionality and said, yep, it's done. But it wasn't on production or even a production-like environment. So when they finally got Solaris stuff there, everybody's happy, all the features are doing, there was only one small issue. They had done some things, I believe it was disk caching if I remember right, that simply would never work in NFS, so they would never work in Solaris. And so it didn't work. So they spent several weeks writing a tool that they called Conan the Deployer. They wrote it in Bash because that's what the ops folks understood. But they then said, okay, every time a CI run is complete, then we now can promote this onto production-like hardware, onto a Solaris cluster to make sure we didn't break anything. One of the people on that project was a gentleman by the name of Jez Humble. Dave Farley was also working with us, not on that project, but different things. And that is really the basis of where this book came from. It's saying, hey, we need to start figuring out as an industry how to do this. So right after the project, they wrote a white paper called the Software Production Line, and then a few years later, this came out. So that all sounds real easy. You just write a bash script, and hence this talk. So you only need to change one thing to do the DevOps. I purposely put it there because you can't do DevOps. That's why the poor English. The problem is it's everything. Okay, so just writing Conan the Deployer, or just getting a certain thing done, or just buying a tool, or just getting a dojo, or what have you, that's not been effective in my experience. So I want to go over some of the changes that I think you have to make to be effective in this. So first off, I think you need to define words or redefine words for your organization. I'm going to go to some definitions later, and I'm going to say this again later. It's not important that you agree with my definitions, but it is important that your organization agree on a definition. Okay, so define what functional test means. Define what done means. Define those words so that if someone on team A says to someone on team B, yeah, I wrote the functional test, there's a meeting of the minds. You know that that means the same thing. I've gone so far in organizations as to put these on posters on the wall. This is what unit test means. True DevOps, I believe, is a culture change, and so you may need to do some organizational change. I'm going to talk about some ways I've seen that work. Modern architectures and technologies, and continuous delivery to safely, I hope it shows up in bold there, deploy on demand. Okay, so first off, defining words. Now, I'm going to show you some definitions, one that I wrote, one that John Willis wrote, some things that I don't think are DevOps, etc. I do this so that you know for this talk and for when you see me, this is what I mean by this. If you want to adopt these, great. If not, fine. But again, it's important that your organization agree. So first off, I like to go into what I think what isn't DevOps, because it's been very convoluted. DevOps is a two-syllable, easy word. Continuous delivery is not. So, now suddenly there's a DevOps pipeline. I would contend there's no such thing as a DevOps pipeline. There's a continuous delivery pipeline that you might use in a DevOps change. Okay, so what isn't DevOps? A tool set. I work for a tool vendor. It's my contention that there is no such thing as a DevOps tool. A monitoring tool is still a monitoring tool. A file system management, a database, a continuous delivery tool, continuous integration tool, whatever it is. I don't know why everybody had to rebrand and become DevOps tools. Also, I apologize if your title is DevOps engineer. I do not mean this to be insulting, but I don't think it should be a job title. It's not a role. It's not a person. That said, in the United States, it's the #1 hottest job. Okay? So if you want to put your title DevOps engineer on your resume or curriculum vitae or LinkedIn or what have you, and you're looking for a job and that kind of thing, by all means do it. Okay, but just understand that DevOps is not a role. It's not a person on the team that does the DevOps. Speaking of that, I also don't think it's a team. Jez Humble likes to joke, creating another silo does not solve silos. What has helped me is to take DevOps and instead of thinking as developers and operators, because now we're leaving people out, so now we have DevSecOps and QA and et cetera, I think of it as the verbs. So it's not developers and operators, it's developing and operating, which is more inclusive. This obviously includes QA, it includes disk provisioning, it's everything, it's developing and operating. John Willis in 2010 came up with the acronym CAMS. Basically you have culture. Now by culture, this isn't just be nice to each other, but in fact, a lot of it is. Psychological safety, like people feeling okay to fail and to object and what have you, according to several studies, is the #1 indicator of a successful software team. So it's not how well you know the language, it's not how good you are at testing, it's not how good your pipeline is, it's the psychological safety of being able to say, yeah, I'm going to try something and it might not work, but I'm not going to get fired for it. Automation is certainly part of DevOps. A lot of people think this is DevOps. So if you're a DevOps engineer, you might be doing pipelines or what have you. Measurement. So continuous improvement, you don't know if you improved if you're not measuring where you are. And then sharing, coming to DevOps days, things like that. Now, Jez added lean in here, and he likes to say comms. I can go either way. John Willis's contention is that he thinks that culture, automation, measurement, and sharing implies lean. But you will find that most, if you look at the elite performers in like the Accelerate, Steady DevOps, et cetera, they're using more lean principles than like pure agile. I can tell you the team that I'm most closely associated with, ThoughtWorks, we don't do sprints or scrum planning or release planning or whatever. We just work on the next most important thing. So this is my definition of DevOps. And again, my ego is not so big that I'm saying you should adopt it, but I want you to know why when I'm here, the rest of this talk, and I talk about things or other talks that you might see from me, this is what I think DevOps is. which probably explains why I don't think there's any such thing as a DevOps tool. Because a culture where people, regardless of title or background, tool doesn't make a lot of sense. Okay, now if you really could change only one thing to enable DevOps, it's probably more your organizational structure more than any technology. You really can't just change one thing, but if you could, this is probably the one. So we'll talk a little bit about a traditional model. And it's funny because this is actually a remake from some Agile slides, so these are not new concepts. But a lot of times we'll have what I'm going to call development teams, and then a testing team. Again, call this what you'd like: compliance, security, QA, et cetera, et cetera. And then the operations team. And of course, you got to draw the walls in between because that's the way this diagram works. The walls, though, here are really the problem. Here is not the software. File systems and continuous delivery servers and all that exist. The problem here is the communication. The testing team doesn't know why the feature was done that way, and et cetera. The operations team doesn't know why the thing was done that way, et cetera. One of the advantages of going first at a DevOps days is I get to be the first one, probably not the last, to talk about Conway's Law. So Conway's Law was actually written 50 years ago. It wasn't about software, it was about systems. But basically, your organization, whatever your org structure is, your design is going to end up like that. So if you have an organizational structure where that group over there does all the credit card processing, guaranteed you're going to have services over there that do the credit card processing, or what have you. And so your organizational structure has a big impact on your architecture. So again, if we go back to our traditional model. Now if you watch carefully, right up here, operations team, changing this to DevOps team does not solve the problem. I have seen this done many, many times. You're no longer a system administrator, now you're a DevOps engineer. What's my job? Same as it ever was. Okay, that doesn't actually solve the problem. The communication barriers are still there. They still don't know why, et cetera. And these folks over here have a tendency to do things like put it on Kubernetes for no good reason, and those folks don't know why, and the why is there wasn't a good reason. So maybe you should have had them and to ask them to begin with. Also, creating a separate DevOps team that creates the pipeline for the rest of the organization is very rarely successful. There are ways to do these as a knowledge sharing. So you take a DevOps team and you embed people on, et cetera. But having a separate team that does the pipeline is not very effective. Also, I have the advantage of seeing thousands of pipelines. Saying this is the one pipeline for our organization is not effective. Mobile apps need different pipelines than CRM apps. Okay, teams should be able to combine their own pipelines. Speaking of teams, this is what I suggest, is product teams that are cross-functional. So the story I told about the Solaris project and so forth, if there had been somebody on that team that understood Solaris at a deeper level, that never would have happened. They would have started to write the code there. The admin would have said, ooh, that's not going to work. Oh, well, what if we change it to this way? Oh, that might work. Okay, and they talk about it and so forth. The developer's not becoming a Solaris admin, and the Solaris admin is not becoming a developer, but you have more knowledge and expertise. Okay, so I'll come back to teams, but we'll talk a little bit about architectures and technologies. And some of this is going to be review for a lot of the folks in here, but that's okay. Now, first off, I want to make it clear that I'm not saying your old monolith needs to be thrown away, okay? There are times to use the newest modern technologies. I'm going to go through a few, et cetera. I'm going to put down monoliths a little bit, but don't think you need to go refactor or rewrite all your legacy software tomorrow that I'm saying you should. That said, monoliths can be hard. So we had customers in the travel agency, travel business, and they had a very large monolith, and we went there because they had a problem where they said, well, we can't react fast enough to change. We're in a very fast-moving industry. We have really good partnerships with airlines and hotels, but we can't get them to our customers fast enough. And so we said, well, how often are you deploying now? I said, well, roughly once a week. It's like, well, that's actually pretty good for an app this size. I said, oh, yeah, but that's actually after a 6-month hardening period. So, okay. So their deploys to production were 6 months plus a week after the code freeze. So it took them that long to get the new special from Radisson out there. Also, scaling was very, very difficult. Okay, so I love driving. Love driving. I had an event in Melbourne, Australia, and then one in Sydney, and I rented a car to go between, or hired a car to go in between. If you're not familiar, that's a 12-hour drive at 100 kilometers per hour. Oh, but it was over 2 days, and I loved it. I would never rent a car here, because I would get killed. Okay, so you need to scale that service more in Australia than you do in Bangalore. But they couldn't do that. They had to scale the whole thing at once, because it's a monolith. So in this case, the right thing was to switch to a microservice architecture for some very distinct advantages. Again, this is not new. Microservices are now, gosh, the book was written 9 years ago. But each element of functionality is in a separate service, and you can scale by distributing these services across servers. And so what happened is they were able to scale down their monolith. Now, they did not rewrite the entire monolith. They only rewrote the parts they needed to scale. I'll get into more in that second. Okay, but they were able to lessen the amount of data center that they had for that, and then do these different services. And now people in their regions and what have you could react much, much faster. They did go to true continuous delivery and started deploying at first once a month, then every couple of weeks, and then eventually on demand. Now, when we talk about architecture, as you probably figured out from the first section, I think definitions matter. If you have two pieces of software, two services that have to be deployed at the same time, or they have version dependencies, I can't deploy to version 1.3 of this until version 2.0 of that has been deployed. That is not a microservice. Okay, it might be a service, but it's not a microservice. A microservice must be independently deployable. If that service shares data, a data source, like the same schema, with another one, not a microservice. Because again, unless you update the schema, if you can't break that one, it's not independently deployable. So when I say break down things into microservices, what I mean is independently deployable pieces of software that you can now change as often as you like, and you're not going to break anything else because they have well-versioned APIs and so forth. And as I mentioned, don't rebuild the whole thing. So in the case of the travel agency, what they did is they built services for the most painful parts, the things they needed to be able to change faster. They changed the calls in the monolith once it was done to those services. Done. Some people call it strangler pattern. They're basically strangling out the monolith. So one by one, they did these services. It took them a couple of years because the project was not to decompose the monolith. The project was to take out these other functionalities. And that was important from a project management standpoint and for management, so that they weren't saying, well, when's the monolith going to be gone? Because that's not a goal. It might end up being that way, but that's not a goal. So build the services where you need to react faster, and build the services where you need scalability. I gave this talk same virtual talk a little while ago, and the day before, March right there, Sylvia posted this thing. I just want to write a script. I just want to write bash. When the deployer was bash. And Jessie Frizzell said, yes, you're doing it right. If you don't know Jessie Frizzell, she's probably one of the smartest people on earth. One of the original core contributors to Docker and Kubernetes, and was a co-author with the Accelerate State of DevOps, et cetera. And so, yeah, don't jump on the shiny object thing just because it's a shiny object. Okay, so back to our product teams. Now what we have is we have teams that own this thing. And so they can get expertise here. They can know more about car rentals. They can know more about how tax payments happen. They can know more about hotels. And so it helps them react to that customer. Remember Amazon's reason for going to the you build it, you run it. It was to know how to react to your customer. Interestingly, this company also went to a point where they stopped doing very much like user research up front. Instead of doing like all these focus groups about what should the new feature be and how should we sell the thing and et cetera, they would write a proof of concept, deploy it, do A/B testing, like send 5% of the audience to the new thing. If sales went up, they built on it. If sales went down, they killed it. So they got rid of all of that, saved them tons and tons of money, and now the entire company became data-driven. The result of this was that the VP of engineering was named president of the brand 2 years later and turned the whole company into a data-driven business. So when you can react quickly, you can make these kinds of choices. So an example of that. Financial services platform. This is a project that's currently going on, happens to be in the US. But it's microservice architecture. You have your old different domains and the different services that run them, and they have their own event stores. We're doing a lot of event-based systems now. So not just inside each service, but the actual system is event-based. And so the apply domain is never going to call an account domain API. Instead, what the apply domain is going to do is create an event that the account domain uses. So let me explain that a little bit. So without events, let's say we're insurance, because everybody knows insurance. So I have a user and I have a user service, and the user changes their address. That affects your insurance quote for a lot of different things, the prices for your home insurance, etc. And so the user service then has to update the quote service and get the new amount. And then it probably has to update billing and a whole bunch of other stuff. Okay, so then as you add new services, you have to add all of those calls, and you have to make sure that you're doing the right versioning, and et cetera. You've probably all done this. With an event notification service, the user service doesn't even know what's using it. Okay, it writes to an event log, and the other services subscribe to that event. So the quote service is just subscribing to address change events. And when it sees one, it does what it needs to do. And that allows me not only to change it around, but I can create new services without even telling the user service. Okay, as long as we have really well-known APIs, there's a thing called contract testing that we can go into like an open space or something later. It's a little too big for this. As long as we can make sure that those aren't going to break on us, I can create new services that consume that event without the user service even knowing. So another thing for storing your data is an idea called event sourcing. So with event sourcing, you don't write to the data store. So you don't make a database ad. You create an event. The event writes to the store. Okay, so the test on whether you have an event sourcing application is, can you completely blow away the store? So there was a system, actually Dave Farley, the co-author of a continuous delivery book, went on to work at a company called LMAX, and they created a trading system, and their number one thing is transactions per second. It had to be fast. And so they put the entire data store in memory with an event sourcing queue. And the event thing would write out, eventual consistency to the database, but of course that's very volatile. If the system crashed, the data that's in memory is gone, but the event store has it, and so they could just play back the events. So what it allowed them to do is they tried all different kinds of technology, end up being a single-threaded Java application that was doing massive amounts of traffic because it was 100% in memory. And it worked very, very well for them. Homework, because you can only go over so much in 40 minutes. And I should, full disclosure, most of the authors, I think maybe even all the authors, are either current or former colleagues. But a couple of books, if you haven't seen them, you should. Okay, so we can do all this, but we still have to deploy somewhere. We still have to put our software on a computer so that people can use it, right? I'm a big fan of a concept called platform as a service. So the example I'm going to use, and I apologize, it's a US example, but in the United States we have an organization called cloud.gov. If you're a government organization in the US and you want to put your application on public cloud, there's a whole bunch of things that you have to certify that you're going to do. And so they started up cloud.gov as a platform as a service. So what that means is there's 325 required security controls. So if they were going to use like Amazon's federal offering, which they have one, they have 325 things that they have to document and certify that they are covering. If they use cloud.gov, they already have approval by the government that they're handling 269 of them. Okay, 41 of them are shared, and then 15 are only by the customer. And I don't remember the exact breakdown, but it's things like DNS and stuff like that. And so now deploying to the public cloud became that much easier. Now this is public cloud, but you can have a platform inside your organization that has 80% of your compliance checks done, that we're only going to use the right version of OpenSSL, that we're only going to use the right versions of operating systems, et cetera. Okay? So the platforms can make it so that you don't have to have all that expertise on that product team. That said, okay, I fly a lot. I've never seen a computer up in the clouds. It really is just somebody else's computer somewhere. So a lot of times when I show this slide that I showed you earlier with the product teams, it's cross-functional, the people who are the blues and greens down here are like, no, 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 no. I did not sign up for that. I want to be a system administrator. I want to build things. I want to do that. I want to tune kernels. That's what I want to do. I don't want to be on a product team. Don't worry, you probably don't have to. We do need that expertise on the teams, but the truth is, in real organizations, you still need somebody that's running that platform. Okay, who's ever had to update a major version of Kubernetes? Good. Don't ever try. It's very, very hard. Okay, but if you're going to run like private cloud, and you're going to run your own Kubernetes or what have you, you want someone that knows how to do that. I don't need that person on my tax team. Okay, so you probably still do have a platform team. This platform team might be Amazon or Google or Azure or whoever, but you have a team that's responsible for updating the operating system and running the version of Kubernetes and all of that kind of stuff. In today's world, you're probably still going to have a compliance team. So, GDPR from Europe. I mean, we're not in Europe, but if a European was here and signed up out here to one of the sponsor drawings and they violate GDPR, the European Union will go after them. It's a law about the European citizens, not Europe. So you have to make sure you're in compliance. And the security teams. Security is everybody's job now. Your pipeline should have as much automated security as it can, but the truth is, hardcore, sit in a dark room and hack, that's a skill set that we're never going to replace. We need those people. And so those spaces are still out there. So I'll come back to these teams in a little bit. We'll talk about continuous delivery. So before we can talk about continuous delivery, we really have to talk about continuous, that says integration. Continuous integration, real continuous integration, is a hard requirement for continuous delivery. Okay, if you don't have a good automated test suite and so forth, and you're looking at doing a pipeline, stop. You're not ready. First thing is to have good continuous integration. Have good automated tests, every commit's going through tests, etc. So at ThoughtWorks, we published a thing called a tech radar, and we identified a pattern we call CI theater. And it's people that are, yeah, we're doing CI because we have a build and test stage and what have you. It's like, yeah, but you're not really testing all the things, and only certain things get tested on certain branches, and it's not really CI. A follow-up study, this is the one that scared me the most, is this one. Downloading Jenkins or GoCD, RTool, or whatever tool does not mean you're practicing CI. Okay, and only 10%. When we said, are you practicing continuous integration, people said yes, and then we went through, like, are you doing this, are you doing that, are you doing the other thing, or what have you, 90% weren't. So it's funny because Martin Fowler and Jez Humble did a blog a little while ago, and as some folks in the audience know, ThoughtWorks likes to poke fun at certification, but anyway, they did the continuous integration certification test. Every developer commits at least daily to the shared mainline. No long-lived feature branches. Okay, if you have a feature branch and it's not going back into master every day, you're not doing CI. Every commit triggers automated build and test. If the build and test fails, it's repaired within 10 minutes. If you have a small product team, you can actually do that. If you have 1,000 people on the same thing, you can't. Okay? It's okay that your build goes red. I'll go into a little later why that is, but it's okay. Now, I actually tweeted this out yesterday. I was reading the Accelerate State of DevOps report that just came out, and trunk-based development is a major indicator to success. But we're also realists, okay? When I develop something, which I don't do a lot of anymore, but when I do, the first thing I do is get checkout-b branch name. Okay, everything's done on branches because I can experiment and throw it away and et cetera. The difference is that branch isn't going into CI or whatever, it's committed to mainline. There's a lot of blogs out there on why, again, we can do an open space on this, I don't have time today, but trunk-based development really is a leading indicator for success in this area. So once you have your CI done, then we can actually move to CD. So this is Jez's definition of continuous delivery. As I mentioned, he wrote the book by the same name, so I'm certainly not going to argue with him. But I am going to focus on that. Safely and quickly, not just quickly. Okay, so the continuous delivery is supposed to get all changes of any kind. So not just software changes, but configuration changes, bug fixes, experiments, so A/B tests, feature toggles, that kind of stuff. all goes through the pipeline. So one of the ways I often explain this is continuous delivery is what you do as part of a DevOps culture. One of the things you do as part of a DevOps culture. Okay, so they're not synonymous. Dave Farley and I give us a couple beers sometimes, and he will argue that DevOps is an important part of continuous delivery, and I will argue that continuous delivery is an important part of DevOps, and people have told me it's entertaining. But what's a CD pipeline? This is a 12-year-old graph. This is what, just so you know what I say when I say CD, we commit some code, it triggers some tests. If they fail, it goes back to the team to fix it, and keeps going along until everything passes. Perfectly okay that it turns red. Okay, if you're not ever turning it red, you're certainly not experimenting much. Now, I do like to point out a difference here, continuous delivery versus continuous deployment. These are often interchanged. Continuous delivery is deploying the software on demand. So when a person, a product manager, the business, a scrum master, I don't care who it is, a person says, okay, we're ready for a release, click. Okay, our tool, GoCD, is continuous delivery. It's deployed once a month because it's on-premise open source software. If I gave you a release every hour and a half, you'd probably be really angry. Continuous deployment, on the other hand, is if all the tests passed, it goes to production. Now, we believe that that is the only difference. There's a lot of people that say that continuous deployment has to be more rigorous in tests and so forth. I would contend that so does continuous delivery. If I really want to be able to hit deploy at any time, I still have to have all the tests. Okay, so let's go back to our teams. What is their role in continuous delivery? One of the things about a DevOps culture is that we want to try to give the development teams a direct path to production. And I do really want this. I want to make it so that the development team makes a change, that it goes through its pipeline and ends up on production without them having to do anything else. This rightfully scares the heck out of a lot of people. Frankly, there's nothing stopping me from writing an app, putting ThoughtWorks logo on it, putting it on a public cloud system, and getting us in trouble. Okay, so this rightfully scares some people. Now, I do want to point out here that CD and CI is not just a couple extra steps on top of continuous integration. There is more here. A lot of times there's, you have to get improvement from like automated change management and, et cetera. It's not just adding the deploy step to the end of your CI. Because here's some examples of things that are bad. Deploying insecure software is bad. Now, you cannot guarantee what you're deploying is secure. You absolutely cannot. Okay? But you can guarantee it's insecure. I mean, if you run a bunch of security tests and they fail, then you know that it shouldn't go to production. Okay, so do that. Non-performant software. There's been study after study that if your web page takes too long to load, or your mobile app or what have you, they're just going to go to the next one. There's plenty of competition now. They all do shipping. I broke my pencil on the plane on the way here. I pinged somebody in the ThoughtWorks office, and one got delivered to the office the next day. Somebody can get one. Non-compliant software. This can get you huge fines. And then the one everybody forgets, ineffective software. Okay, software that you deployed that made your sales go down or made no improvement. It passed your user acceptance. It did what the user story said it should do. It's pretty, it has nice user experience, whatever, but people aren't buying more Surface Pens. Okay, so we should be testing this too. This is what I mean by you can't prove something's secure, okay? I also can't prove it's good. The purpose of a continuous delivery pipeline is to kill a release candidate, full stop. Every time you make a code change, or a configuration change, or a database change, or whatever, that is now a release candidate. It's the pipeline's job to prove it's not good enough. That's why breaking the build is not something, I've been in the industry for a long time, and the builds that we were doing 30 years ago took hours, and they had dunce caps if you broke the build, and et cetera. Please don't do that. Okay, breaking the build's okay, because if we're building constantly, then all I have to do is go back to the last 15 minutes of code and fix it. It's not a big deal. That's what it's there for. It's a safety net. So if we go back to our pipeline, what I would want to encourage you to do is run other pipelines in parallel with the development team. Now, I don't mean other jobs on the same CI pipeline. I mean entirely different pipelines. So if I create a new thing, I'm a development team, and I create a new Docker container, I have another pipeline that my security team owns where they've written the tests, and it's looking at their tests in their source code repo that will grab my container, my Docker container, and run a bunch of security tests on it. While that's happening, my functional test and deploy stage, that's still going on. I'm not blocking it. It's not in line. I'm not going to say I can't do staging until those have passed. I'm not saying I can't do that until functional tests have passed. It's in parallel, so hopefully it's not slowing down the development pipeline. I say hopefully, because if that's a 5-minute development pipeline, there's not very many security tests, but hopefully not much, okay? Same with compliance things. Did they use a port? Is a port open on that container that's not supposed to be? I've seen this fall too often. Are there secrets in the container? Okay, and maybe that's a security test. Okay, but there's all kinds of things that you can run in parallel where you can say it's trust but verify. Okay, dev team, I'm going to let you define your own pipeline. You can run your own stages. If you want to do single stage, build, deploy, fine. But I'm going to block your deployment until these are done. Okay, so the modern tools can mostly do this. Now, I do have to say, there isn't a silver bullet, okay? So that's why, that's actually what led to this talk, is people would say, oh, I bought the latest tool, latest ALM platform, now I'm on the cloud, whatever it has, I'm all solved. It's not. There is a lot of work to do. The good news is that, the term DevOps was created for DevOps Days, actually, 10 years ago next month. The 10th anniversary is at DevOps Days Ghent. The Continuous Delivery book came out in 2010. And so these are solved problems. There's lots of materials out there. These are just some that I picked basically at random that will help you along some of these. If you haven't read the Phoenix Project, anytime today is fine. It's actually fiction. It's a quick read, but it tells you about lean stuff. And if you get your mind into the 3 ways of lean, that might help you understand a lot of this. And then the others, of course, are important as well. And so, for a summary, I strongly believe that you have to have definitions. Okay, you do not have to agree with, please don't, just say, oh, well, Ken said this is the definition of DevOps. Donovan Brown has a great definition. Unfortunately, Patrick and Andrew, the people that invented the term DevOps, they actively refused to define it because they didn't want it to become something that people would then say, okay, here's a class, are you doing the certification? Sorry. You may have to change your org. In fact, this might be the one thing. Don't decompose your monolith for the sake of decomposing it. But if you're having the problem of, I need to be able to react faster and so forth, often it is the architecture that needs to change. There's a gentleman by the name of Gary Groover that worked at Hewlett-Packard that enabled continuous delivery on printer firmware. What? They had to rewrite the firmware to do it. They had to rewrite it in such a way that it was now conditionals for different printers, and I won't bore you with all the details. But if HP can do it on printer firmware, you can do it on your software. But it might mean rewriting your software. Might not, but it might. And again, CDs to safely deploy more often. Okay, I'm really happy that the Accelerate State of DevOps went from deploys per day to deploy on demand to define elite performers. Okay, please don't set a metric of deploys per day. Because, I can just write a line of code, deploy, write a line of code, deploy, write a line of code, okay, it's gamed. Okay, if, time to live is important to you, how long from a feature request to done, fine, measure that. Measure your lean. If you haven't done a value stream map on your process, do that. But please don't use CD solely for speed. And with that, I will say thank you. If that's accurate, I think I have 1.5 minutes for questions, if there's any. And I'll be around all day, too, and probably all day tomorrow, too. Up front.
So that was a good presentation, but I have a question here that how do you create the discipline to get to the CI stage? CD is far ahead. In CI also I've seen everybody starts with a big bang, and once you get into a time when the schedule starts coming to a pressure stage, you forego all the tests, let's put it across, let's take it to the next stage, and everything is broken, right?
So you have a code base now that doesn't have enough tests for CI or that kind of thing, or?
You start with all the tests we are not going to take in before all these automated tests are done. but somewhere if it breaks down, something across, you don't push back into you have time pressures for the schedule, and that starts commanding you more than the quality. Now, how do you balance between both of them and take it ahead so that you don't break it ahead?
Well, that a lot comes down, frankly, it's not a technical question, that comes down to the psychological safety thing of can we do things and let it break, and then do we have the freedom to fix that before it can go any further? How often have we all said, well, that's red, but I know it was red because it was a network thing, don't worry about it, just hit, whatever. That's a culture thing that has to be changed for the most part. Now, the part of the question you didn't ask that I thought you were asking is, well, I don't have enough tests. One of the things that if you're going to try to implement this on an existing code base, I know a lot of people don't like this, but if you switch to a model like test-driven development, your new functionality will get unit tests, but then as you're fixing bugs or refactoring or whatever, your test base changes. People that they want to implement CI on an existing code base, they say, oh, now we're going to go write a bunch of unit tests. It almost never works. They're all happy path. So we can chat more if you want, because I know that was pretty vague, but just looking at the clock. Okay. All right. Thank you very much. Oh, I'm sorry.
Hey, Ken, it was a very nice keynote speaking.
Thank you.
So one thing that I would like to see is, we talk about DevOps and DevSecOps kind of thing. Where do we see the performance in this part? I mean, we do see the security testing, normal testing, but where is the performance testing?
So I often, I think my slides are off. I often, the thing where it said security and compliance, I will often put performance on there as well. It just wasn't room on the slide. Performance testing is another thing that usually takes a little bit of expertise, and I like to do that. That said, a lot of continuous integration, continuous delivery tools will do like high-level statistics. And so like we have a thing on ours called analytics, where I can see how long the pipeline's taking, and that is an indicator of a performance problem. We actually don't run the performance tests on every build because they are super expensive. But we do watch the analytics, and if like the regression test or functional, whatever, if that's getting longer, it's like, okay, wait a minute, what did we do here? And now we can, on demand, run a performance test on it. But it's in that same category, for sure.
Follow up to that question, Sam, the compliance and security testing that we are doing.
So you cut out, hold the mic still.
So follow up to that question, right? Like we talked about continuous delivery and continuous deployment, where delivery talks about manual deployment and deployment goes with every check-in goes to the production time, right? So when we, and again talking about doing the security, compliance, and the performance outside the normal pipeline?
I'm saying in a parallel pipeline. Most of the compliance tests can be automated as far as the actual compliance requirements. So now a lot of organizations will put in compliance things like separation of duties. Only certain people can deploy, and they can't be the same people that wrote the software. The truth is, unless there's something different, most of the European and North American laws at least, that's never actually called for. Organizations do that as an extra safety net, but it's not actually required. If it was required, what you could do is, remember the continuous delivery, there was a push button? That could very easily be the person that does, what have you. But there's lots of good compliance testing automated frameworks out there now.
We have time for just one last question.
So my question is more around the trunk-based development and the branch-based development post you have put on Twitter. Consider a scenario where we have a couple of folks working on one particular feature, another group working on another feature. In this scenario, which deployment commit strategy would you suggest?
So they're both committing all the time. In fact, that's the exact scenario. If you go to martinfowler.com, there's a thing there on feature branches. So you have people working on different features, and they're both committing. And one of them, they're going to break each other. They absolutely are. They're going to have merge conflicts, et cetera. But they're small. And so, especially if it's a small product team. So they can do a merge or commit and get a merge conflict. And they can say, hey, Sue, I get a merge conflict here for the thing you wrote today, because we're doing it every day. Oh, okay, yeah, I did that because this. They can talk about it, and then they fix it. In our experience, when you're fixing those merge conflicts at the end of a 2-week sprint or something like that, the mindset's not even there. You don't even know why you did that thing. And so it's not going to lessen the conflicts, but it's going to make them much smaller and more often. There's a thing John Oswald said, I think it's John Oswald said, bring the pain forward. But if you like, I can turn you on to the blog later about it. It's definitely a change that people have to get used to. And it requires other things, like there's a concept called feature toggles, et cetera, because now you have in-progress features on main. And so now how do I disable those until they're actually ready to go, et cetera? Again, like everything I just went through, there's a lot of intertwined changes that are required. Okay. Thank you very much.
Thank you again for defining DevOps